Okay. Hi, this is Erin, and talking through questions 7, 8, and 9 from my quiz. So this one's about a reflected light beam on a block of glass immersed in water. And since we know what the frequency of the light beam is, we know that that's going to be consistent throughout different mediums, air, water, glass. And so then what we do is we have this. We know that the angle of incidence is larger than 47.8 degrees. And so we take basically what each of these reflection indexes are, and we put into the equation. We basically need to figure out what is the refractive index of glass. And so we know using the equation of the refractive index of water, which is 1.33 over the sine of the angle, which we were given as 47.8 degrees, and we get the refractive index at approximately 1.8. And then find the wavelength in nanometers of the light and air, kind of the same deal here. So we know that the speed of air, is that what it is? C? Yeah, speed of light, excuse me. Speed of light is 3 times 10 to the 8th power. And so we just divide that by the refractive index of glass, 1.8, and we get 1.666667 times 10 to the 8th power meters per second. And so we can plug that in to find the wavelength using the equation V over velocity over frequency. And we already have the frequency that was given. And so plugging that in, we get 305.5 nanometers. I guess I could round to 306 nanometers as the wavelength. Seems pretty big. And then find the wavelength in nanometers of the light in the glass. So again, F is constant, and so we got to find what is the wavelength of the air. And so again, taking C over F. Oh yeah, we just plugged it in for C over F, and then I got 550 nanometers as the wavelength. Okay, that's all for now, folks.